All right, we are looking at lesson 82 here in Saxon Math 54. And lesson 82 is talking about tessellations. So, tessellation is simply a repeating pattern. In math, there are tons and tons of patterns. So, we're going to be talking about tessellation because it demonstrates a pattern, and the more you recognize the patterns, the better you'll do in mathematics. If you haven't already, do these warm-up problems right here. Notice you're looking for patterns. And right there in the warm-up, it's asking you to look at the pattern and recognize a pattern that is happening in the drawing of those three images there. Okay? So pause the video if you haven't done these already, and then come back and we'll continue. All right, today's new concept, as mentioned, we're looking at something called tessellations. And basically a tessellation is taking a shape and having it repeat over and over and over and fitting them together so there are no gaps and no openings in the pattern. You're basically kind of like filling a floor with tiles. That's kind of the idea. He talks a little bit about how archaeologists found people using tiles way back even as early as 400 BC, before Christ. And so we get the word tessellation from the Roman word for tiles. All right? So here's some examples of tessellations. You can see the basic shape here is just a triangle. If you take that triangle and you fit that same triangle, the triangle shape can't change, but you can rotate it and spin it so that they can all fit together and fill up a flat surface. Here's another one. Here's a hexagon. Hexagon has 1, 2, 3, 4, 5, 6 sides. This is a regular hexagon because all of the angles are the same measure as well. And you can fit all of those hexagons together. Again, there's no openings, no blank space on that floor. Here's a quadrilateral. Has 4 sides, 1, 2, 3, 4. So looks like every triangle, every hexagon, every quadrilateral can tessellate if you want it to. They can fit together in order to fill the flat space. So here's just some quick instructions on how to maybe make a tessellation, the repeating pattern. You start with any tile, and you want to make sure that you can transform that tile, that shape, if you want to, so that it can be kind of a little creative, a little different. But you're going to take your original shape, let's say a triangle, and then you can make the next one and you rotate it 180 degrees. All right, and then you can start to fit them together. So the idea is that you can take our 3 shapes here. We said triangle, hexagon, quadrilateral, and you can repeat those and then turn them or shift them or move them, make a transformation in order to fit them all together so there is a repeating pattern with no open spaces. Okay? So it says here every triangle and every quadrilateral can fill a flat surface, even if the triangle is a little bit different. So you see here, here's a triangle. It's not a regular triangle. It's not equilateral or equal angular. And they've just adjusted a little bit. But still, you can take this triangle right here and fit it with another one that's a little bit kind of upside down, and then the third one, and then the fourth one, and you just keep fitting them together until you fill up the entire space. Here's a quadrilateral. 1, 2, 3, 4 different sides, and they've adjusted the quadrilateral a little bit, so it kind of looks like maybe like an arrow, and you can fit those together. So this quadrilateral here, and then you turn the next one upside down, and you can fit it together, and you just keep fitting them all together, and you'll see that that quadrilateral is indeed making a tessellation. So you can do this activity right here, which talks about going to Master 14, and you are going to cut out the triangles and the quadrilaterals in that activity and begin to form your own tessellation. Okay? You can also look here and you can take these shapes. For example, here's a quadrilateral, 1, 2, 3, 4 sides, and you can, on a piece of paper, just trace it. So you can put a piece of paper over this shape and trace it, and then trace it again, but you're going to rotate it, so flip it over, right? So the next one's going to be flipped over and it's going to fit like that. And then you're going to trace it again, maybe on top, so you can begin to fill this with your tessellation. Okay? So use that shape and trace it, but turn it and twist it and rotate it so that all the same shapes, the same quadrilateral, begin to fit together nicely and fill your piece of paper. Does this figure tessellate? Here, this is a pentagon. 1, 2, 3, 4, 5. 5 sides. Is that going to fit as well together, even if you turn and rotate it? Well, pentagon doesn't work quite as well. As you can see here, here's a pentagon. So this pentagon right here, it has 5 sides. 1, 2, 3, 4, 5. Even if we turn it and rotate it together, you'll notice that right here, 3 of them trying to fit 3 together, you're going to have a little gap here, and that gap is not going to be filled by another pentagon. So a pentagon doesn't work very well. If you want to have a little bit of fun online, there is a website, and that website is shown for you right here. So you could type that website into a web browser, and you can make a tessellation online. So you can choose the shape that you want. For example, we could do a triangle, and then you actually could just tessellate a triangle if you want to. You can choose different colors like red and blue, and then just hit tessellate, and you'll see it'll automatically make a tessellation for you using that pattern. But it'd be nice if you did something a little more creative, and you could reset this, and then you can edit this triangle. So you could edit the edges here. So you could grab an edge and make it twist and turn a little bit. Grab another edge, make it twist and turn a little bit. Okay? So really it's a triangle, but you just kind of bent it. Now if you take that same triangle and we choose maybe the same colors, red and blue, that's fine, and I hit tessellate, you'll see it'll automatically tessellate it for me. Now what it's done is it's taken the shape that I had here and it's squeezed in a different shape. So you're actually using 2 different shapes in order to tessellate. So you're tessellating with 2 different shapes here, but using those 2 different shapes in order to kind of fill up the pattern. Okay? You could take another one here. This time let's use a rectangle, and we could edit the edges. You can also edit the corners, meaning you can kind of spin this whole thing or make it shift like that, and you can play with it a little bit, and then once you like the shape you can hit tessellate and see if it actually does tessellate. So if that shape is repeating just by itself, then that shape will tessellate. If it needs another shape in order to complete the pattern, then that single shape doesn't tessellate. Okay? So play around with that. It's kind of fun. Let's go back to the lesson here. And that was basically the lesson on tessellations. You just have to understand a repeating pattern and be able to maybe create a tessellation or recognize one. So let's jump into the mixed practice. Here's where you want to pause. Go ahead and do the problem set on your own, struggle through it, and do all 30 problems, and then come back and just check on any help or hints that I may give you here. Okay? All right, we are talking about the mixed problem here, the mixed practice problem set, and let's look a little bit at number 1. So in number 1, it says there are 35 students in class, but only 28 math books. How many more math books are needed so that every student in the class has a math book? So if you got 35 students, only 25 books, 35, 28, how many more do you need? How many more books do you need to get up to 35? So I need 2 more to get up to 30, and then I would need 5 more to get up to 35, so I need a total of 7. So you can do 35 minus 28 is 7, or 28 plus 7 is 35, however you want to think of it. All right, number 2. Each of the 7 children slid down the water slides 11 times. How many times did they slide in all? So each of the 7. So one child goes down 7 times. Another child goes down his or her own 11 times, sorry. So each child is sliding down 11 times, so that's 7 times 11 is going to give us 77 total times that they all collectively slid down the slide. Bowling lane is 60 feet long. How many yards is 60 feet? There are 3 feet in 1 yard. So if you've got 1 yard, that's 3 feet. 2 yards would be 6 feet. 3 yards would be 9 feet. So you can see all you have to do is take the number of yards that you have, and you would multiply that by 3 to get the feet. But if you have feet, you would have to divide by 3 in order to get the number of yards. So if I know the feet, if I take 9 and I divide by 3, that would give me the number of yards. So if I look at a unit multiplier, it would look like this. If I have the number of feet, in this case 60 feet, I know that 3 feet is equal to 1 yard. So I'm multiplying by what's called a unit multiplier. 1 yard and 3 feet are the same length. The feet are going to cancel, so this tells me that I need to take 60 times 1, which is a 60, and that's like 60 over 1 there, and 1 times 3. So 60 divided by 3 is going to give me yards. So 60 divided by 3 is going to give you your 20 yards. This is a very powerful skill, multiplying by unit multiplier, that you'll see a lot in math and science. Okay. Willis carried the baton 440 yards. So 440 yards. I'm just kind of gathering information here. Eric carried it 880 yards. 880 yards. Joe carried it 1,320 yards. And Braulio carried it 1,760 yards. In all, how many yards was the baton carried? So you're going to add up all of those numbers there. Okay? 1/3 of the members voted no. What fraction of members did not vote no? So if 1/3 voted no, that means the rest of the fraction, that would be 2/3, voted yes, or they did not vote no. Round 6,821 and 4,963 to the nearest 1,000. So 6,800, that's going to get rounded up to 7,000. 4,900, that's going to get rounded up to 5,000, and then add those together. What fraction of the days of the week start with the letter S? Well, we've got Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So Sunday and Saturday both start with S. That's 2 out of a total of 7 days in the week. Together, Bob's shoes weigh about 1 kilo. 1 kilogram. Each shoe weighs about how many grams? So together, Bob's shoes weigh 1 kilo. So that means each shoe, assuming they're identical, each shoe weighs about how many grams? Well, 1 kilo is 1,000 grams. But that's for 2 shoes. So for just 1 shoe, you have to take 1,000 and divide by 2 to get your 500 grams for each shoe. Use the line graph below to answer questions 9 through 11. Okay, how many pounds did Juan weigh in his 2nd birthday? So here are the ages down here. So this is when he was born, at year 1, year 2, 3, 4, 5, and this is the weight in pounds over here. So on his 2nd birthday, that would be right here, we need to go from this value up to the graph, find the point, and then go from that point over, straight over horizontally to the y-axis, which gives us the weight, and it looks like it's right between 20 and 30, so we would probably estimate 25 pounds. How many pounds did Juan gain between his 3rd and 5th birthday? So 3rd and 5th, 3rd, we're here, 5th, we're here. On his 3rd birthday, he was 30 pounds. On his 5th birthday, he was 40 pounds, so he went up 10 pounds. Copy and complete this table using information from the line graph. So It's already filled in for you. So all you're doing is looking at the graph and reading the different values for the weights at different years. Okay? If 65% of the lights are on, then what percent of the lights are off? Remember, percentages of a unit, percentages of something always have to add up to 100. So if 65% are on, then the remaining percent, which would be 35%, 65 and 35 add up to 100, would be off. Okay, all of these you're going to do on your own. So 13 through 24, you can work on those and just keep practicing on those. Remember, every equation asks a question. Okay, remember to do exponents before adding, subtracting, before multiplying, etc. And then let me know if you got questions on those. Okay, 25. If 3-inch square is covered with 1-inch squares, how many of the 1-inch squares are needed? So if you take this 1-inch square here and you start to fill up the 3-inch square, in other words, we'd take a 1-inch square and use three 1-inch squares to go across the row, and then you would do that again. And you do it again. And how do I know how many are going to fit? Because if this square is 1 by 1, then I would have 1 by 1, and this would be 1, and this would be 1, and that would be 1, 1, 1. All of these squares are, the sides are 1 inch in length. So that tells me that 1, 2, 3, 4, 5, 6, 7, 8, 9 of them are going to fit in there, because I'm going to put 3 across and 3 down. 3 times 3 is 9, and that is inches squared. Perimeter. Perimeter, you're just going to add up the distance around this object. There are 3 sides, and you're going to add them all up. And notice that all the units are the same here, so you don't have to worry about changing units or converting anything. Just add them all up. Which of these letters has line of symmetry? Remember, line of symmetry is going to divide it right in half and have 2 equal parts. So Q, no. R, no. S, doesn't look like it. T, I think, is the only one right down the middle of this T is going to have a line of symmetry. Okay? Write the capital letter P, rotate it 90 degrees counterclockwise. So if you take the letter P, and then we're going to rotate it 90 degrees counterclockwise. Well, the clock, the hands of the clock move this way, so we're going to go counterclockwise, back the other way. So we're going to take this P and rotate it 90 degrees. So just take one point right here and rotate it 90 degrees. So it's going to be here, and then draw your P again. So it's like a P that's kind of on its back, all right? Just like that. 3 of these triangles are congruent. Which triangle is not one of the 3 congruent triangles? So again, what you want to do is a congruent triangle, they should completely overlap each other. Like if they were to lie on top of each other, every point would match up. So you could maybe do a little bit of a visual inspection here. A and B, if you took A and B, and if you flipped A, you could flip A and have it completely lie on top of B. You could also spin or rotate C and maybe even flip it and have it completely lie right on top of B. But D has different angles and different lengths of the sides, so it is not congruent. D would not be congruent. 30. The radius of the circle is 1.2. Radius is from the center of the circle to any point on the edge. What is the diameter? The diameter is all the way across the circle from edge to edge through the center of it. So if the radius is 1.2, then this over here is 1.2 as well, and the 2 of them together are going to give you the entire diameter. And you just add those 2 together. 1.2 and another 1.2 is 2.4 centimeters to give you the diameter. All right? Let me know if you got questions. I went kind of fast, but you can pause the video at any time. So don't just watch it and just kind of like you're watching a TV show or something. That's kind of passive watching. You want to watch it actively, meaning if you didn't understand something, pause the video, go back, watch it again, or pause the video and make sure you understand it maybe before, and then check with the video to see if it clears it up. All right? Keep up the good work.